So, good afternoon. This is Ben from Swift-Cut Automation. Today we're going to go through some of the basic principles of using the SwiftCam software. Some of the information with regards to nesting, as well as going through nesting principles, lead-in changes, all the way through to ultimately getting the Swift-Cut machine to actually cut the profiles. So there's a few things that we'll go through on this. What I'll do as well as we go through the principles and through the details is I'll make sure that at the end we see one of the machines that's taken one of the codes that we've created. So in our case is the G-code, and get that cut in on one of the machines. Just to give you a background for those of you that don't know, we're Swift-Cut Automation are a CNC plasma and water jet machine manufacturer. We've got different distribution networks across the globe, and we do specialise in running our systems with the hypertherm plasma systems. So on the video that I'll show you a little later on, there's on there the one of the tables is our Pro Series table running, which has got a PowerMax 125 running as part of that system. So I'll make a start on this 1 second. So the SwiftCam software, when you start this up, it's a software that allows you to create the job. So it's split into a couple of different parts of the software. So you've got the SwiftCam software, and then you've got the CNC side of the software. The SwiftCam side is the aspect of creation of the job. The CNC is obviously the runnering part of the machine itself. So whenever you load into the system to get a job created, this is the screen that comes up first. You've got a previous jobs library that appears on the left-hand side. This can be for the jobs that you've previously put in, and again that'll just create as a long-running list, so you can go back into them to adjust or to change or to reload for any reason in there. The first step to creating a new job up here is the New Job button. So the New Job button allows you to customize both the classification and the job name as well. So the classification side can be the name of yourself, it can be your company name, it could be the project that you're working on, it could be anything that you can effectively associate to help you find these drawings or these nestings when you come back to them. I'll leave that as standard. The job name, again, it drills down a little bit as well. So this gives you the ability to put in the job name so you can find the individual components. So if you've got a project for a certain customer, you can use the customer's name as part of that, and then the job name can be formed underneath. The reason for doing this at this point is it actually creates a file hierarchy further down the line. So when you're actually creating the job itself, you can then find it by going into the folders, and you can see it'll be in classification and then in job name as well. The next section of this is actually the sheet dimensions. So at this point you get the opportunity to put in the size of the material that you're effectively going to be working on. So in here we've got this set to 3 meters by 1500. Again, if you've got offcuts or different sizes of material, all the way through to if you're cutting and you've only got, say, a meter square, when you're coming to do a nesting, it's going to form an integral part of that. So you put in the associated sizes that you've got to allow the nesting aspect of this to take place. Material is a drop-down menu, so this covers as standard. It'll do aluminium, mild steel and stainless steel. The other materials can be programmed within this, but these come through as standard. And the thickness is directly associated, partly to do with the material that you're putting onto it, but also to do with the size of the plasma unit that you put in to connect this up. So on the case of this one, we would be looking at a PowerMax 125, and using the 125 we would have a thickness range of between 0.5mm and 25mm. Again, if you use a different plasma source, a smaller one, for example, like a PowerMax 45, that'll be in a range between 0.5 and then up to 12mm, so that's selectable. The trim values that come with this as well. So trim is the distance from the edge of the sheet or the piece of material to the parts themselves, so you don't cut off the edge of the sheet, and if the sheet isn't perfectly aligned, it allows you to keep it within that scale of the sheet itself. And then part spacing. Part spacing is literally the size, the distance and the gap between two objects that you're nesting on the plate. With this as well, if you've got a particular size material, it won't allow the part spacing within the software to be 0. So within this, if you leave it at 0, as I'll do in this case, and click OK, it will actually tell you that because it can't allow a 0 gap, so it won't allow them to nest over themselves on the part. And by doing that, it just means that you're not going to lose parts unnecessarily, and you then need to select the yes to say you agree with that. So from this point, we've got the options on the left hand side, so within File, Parts and Parameters, to be able to load items in. And then here on the big screen on the right, this is the parts that we're actually setting to cut out on the piece of material that we're going to work with. So from within File, you can select items and locations within your machine. If you've got a USB key drive plugged in, you can select that by selecting the options and go to the different locations. And from this, you can select DXF files, you can select DWG files. You can also load certain image files into this to allow you to use those to convert to a cut path. But as standard, DXFs and DWGs are generally the way forward and accepted within the software. The parts list, which is another drop-down selection tab, within this, it's all the parts that you've previously loaded into the system. Once you've created them as a part in here, it will save automatically into the parts list. Now, the parts list is very good in the respect that it is filterable by the materials that you are working on. So if you load a full sheet of material onto the system or onto the bed, and you nest the parts that you need, and there's a small gap at the top, you can filter the components within the parts list to effectively fill in the gap. So you can filter them by thickness, select a couple of the parts that you want to cut extra, and load them onto the material as well. So it just gives you that added extra to do that. It also means that if you put the part code details in correctly with all the correct part codes, as you go through different jobs and different creations of nestings, you can then refer back and pull parts in again. So if you've got specific sites, for example, where you use certain plates, you can actually just load them in from the parts list without having to keep loading them in multiple times. So that's where the parts list comes in useful. Finally on here, we've got the parametrics library. Now, the parametrics library is very useful, and a lot of people do compliment this. So it's basically 89 shapes, and I'll scroll through them just so you can see a rough guide of those. But it's basically 89 shapes that are fairly common. Base plates, flanges, corner pieces, all those sort of things that you don't necessarily want to spend the time drawing up necessarily. But what you can do with them, and I'll open one of these up, for example, this one, it allows you to go in and actually change the dimensions based on specific points on the image itself. So you can see point A here, which is the overall width of the component. This is currently set at 100 mil. You can change that, you can adjust that out or pull that into whatever you need it to be. And the same goes for obviously object B, C, D, E, and F. There's a lot of different components within here. There's a lot of different variants to what you can and can't change. So from this, you can actually go into it and get the parts and the components together. So I'll select that as it is. And here's the component that we've put in based on the sizes that we were after. So the part on the left hand side here, this is the item as it currently stands. The part on the right, this is the component as it's going to cut out on the machine. Now, the machine in question that this is set up for actually has on there a couple of the extra tools. So it's got in here, it's got the engraving tool as part of the setup. Now, if you know, for example, that you want to put on here, say for example, this centerpiece here is where you're going to be welding on a pipe later on. Instead of cutting that or just trying to find it afterwards, the easiest way, you can actually use the marking tool, this one in green, select that center hole, and as you can see on the right, it's changed that. So what it's going to do is it's going to etch using the marker tool that circle onto here, and then it's going to cut the rest of the components. As standard, it will always set it to cut. After that, you get the option then to look at changing this. The other alternative to this is the center pierce tool, which is the red one. So again, if for example this component, this hole in the center here, wasn't a hole, it was a position that you wanted to drill out afterwards, because in say 20mm material, the general 2D rule applies, so you wouldn't be able to put a very small hole through the 20mm thick plate using a plasma system. So what you could do in this situation is using the center pierce tool, select that center pierce again, and it goes darker over here on the right, and what it will do is it'll, using the plasma itself, it will just pop a mark right in the center of where this hole will be on the component itself, just allowing you afterwards to line it up on a drill and then effectively just to pierce it out, and then you can cut from it from there. Once you've completed how you want to set this part up, you can select next. Again, you get the option here to change the part name, so I'll change that to test. Classification, that's already been set from previous, but you can adjust it. You also have the opportunity to set a description if you want to be able to refer back to it at any point. Save that, and that will save that back to your parts library, and you get the question now of how many you're looking for. So I'll say in this occasion I want 20. Click OK, and now on this right hand section it's loaded the part in as we've put it in with all the details for a quantity of 20. At this point you can load other components in, other items, other parametrics or DXFs to build up the job of what you need based on the material thickness that you're working to. Once you've loaded them all in, select next. Now from this software there are two versions. So this is the automatic nesting software. There's another version which is the standard software. So in the standard software you would get on the right hand side, you get here a list of the components that can go onto the sheet that you've put together. And by selecting those and the place button, you can place them onto the sheet of material. With the automatic nesting software, a little bit different. As you go to the next function, it will effectively do an automatic nesting as it's done here onto the sheet and loaded them all into the orientations that it is best based on the technology that's built into the system. Once you've done this section, click next. Again, this is saving information back to the parts, and it will look at the nesting and it will then look at the tooling. So you can see, and I'll zoom in on a certain side here. So with regards to the externals and the holes, because we've set this to center pierce, it doesn't need a lead in and lead out. The holes here and the external parts of the profiles, lead in and lead outs applied to them. These are automatically generated based on the information that is built into the system, but you don't necessarily have to agree. Not only that, you may need to move them just because you know what the component's going to be used afterwards, not all the time. So again, there are certain options across the top to do trims and adjustments. One of the options is this, which is lead in modify. So lead in modify again allows you to select a lead in, as we've done here and highlighted this one. And on the right, we've got options to move it. So we can just click a different position and it will uniformly move the lead-ins on these components to the right point. So it's an ultimate point. You've got lead-in apply to all parts. So if you want to change it on all of them except one, you can take the lead-in locked off and then not apply it to all parts. So it just keeps it onto one. Or the lead-in locked again, it makes sure the parts can't be moved and the lead-ins can't be moved from there. So once you've got that and you've got your lead-ins and details applied, you can tick that. And then you've got the next function. So the next function brings you into the GCode Creation. So it's at this point really that you've completed creating the job, and you can see this by the part code generation, a logo with an icon that comes up at the bottom. So on the left hand side you've got all of the details for the creation of the part itself. So that's the machine language and G-code that will be used to run the machine. Most importantly on this as well is across the top you actually get the consumables that you need to put into the head end of the machine in order to make this system work and cut to the right settings that you've got. So it states here, please use the 125 amp consumables, and it actually gives you the individual component part numbers for the hypertherm components that need to be loaded into the torch in order to make this work. As part of that generation process, it also produces a PDF. So the PDF is very useful for a lot of people, and it basically is the job card that is required to get the machine running. From a point of view of it gives you the information for the operator to be able to set it all up. So the operator doesn't necessarily have to go through the process of creating the job. They can just be given this job card. From this it'll tell them the size of the material, the thickness and the type. It'll also tell them how many parts or sheets of that size are required, all the way through to any trim value, so how much of the material is being used, where it's saved as part of the file names, the overall weight, scrap percentages, and then cutting time and quantity of parts on the material. So useful for 2 points. One is obviously on the machine itself. It'll allow you to cut the program and check against it. Also, if you're doing any costings, from the costings side of things, you can use the weights for the material. So if you're doing mild steel, you can work out your cost price for the material and understand it based on this kilogram weight for costing. And obviously the cutting time. So if you've got an hourly rate for the cutting, if you're selling this out or you want to work out an internal cost, you can use an hourly rate and then base it on the time itself. Within this sheet, we do get the consumables list again, so it also retains the information on your required consumables. It gives you a rough copy of the overall nesting, details of the individual components, so the individual component size, all the way through to its area, weight, and how many of those should be cut. It also gives you an individual line item based cutting time as well as a component cutting time. And then if you go further down, it actually gives you a parts list, which is almost like a tick list to make sure that all of the parts get taken off the bed itself. So that's automatically generated as part of this process. So again, at this point, you've created that. You can't click next any further. You go now at the point where you can load this into a machine. So this is the second part of the software. This is the CAMS or the CNC side of the software. This is the bit that's actually on the console as well to allow you to set this up and run the program. So the basic steps to run through on here is you'll always need to make sure that you've used this reference all button when you start the machine up to make sure that the machine is completely referenced. Then you've got your 0 X and Y and 0 Z buttons. So the 0 X and Y and 0 Z buttons allow you to get to the very bottom left hand corner of the component to allow you to start the positioning of where you're going to be cutting from. So in this case, you will load the G-code, find the one that we've set up, which is this test file. And you can see over here on the right, these components are loaded in, ready to go. You will then, using the 0 X and Y and the arrow keys or the keys on the keyboard, position the torch over the corner, the very left-hand corner of the component. 0 X and Y, so that's your start point. 0 Z, which will bring the soft sense foot down to do its the soft sense check on the material. And once they're on alignment and you're happy, you click Run G-code. So at this point, you've got your consumables in, you've set all the positionings up, you've loaded the program in, you've got it all set, and as soon as you hit G-code, it's ready to run the program. And the program will run pretty much as it's required on here, like this. So there we have it. There's the run through of our Swift-Cut CNC control software that runs on all of our tables. This specific table, like I say, was the Swifty Pro series table, which is an available table. Again, we've got facilities for demonstrations, which we can do online. We've also got literature and further details on these, so if you've got any questions, any queries, or if you'd like to discuss these machines with us, again, we're available. Either email us on sales@swift-cut.co.uk or drop us an email within Instagram, and one of the team will get back to you and we can go through the details from there. So thank you ever so much again for your time and for watching this. I hope it's been of value to you. The next one, I believe we're going to be looking at our XP range product with the Max Pro 200. So that's the next one planned in. We'll keep you posted on when that's going to be. But for now, thank you very much, and I will speak to you all soon. Thank you.